In this video, I'm going to go through the answers to the reaction profiles quiz that you did. I'll just go through each one individually. They might not be in the same order that you did them in because I randomized the order on the quiz. So, but you can look at this and it will remind you which one it is. So, this one to start off with, nice and easy. So the activation energy arrow, no problem there. It goes from the reactants up to the top of the curve. I might not have got it 100% in line here. Sorry about that. Some people did point that out. You might want to, take a ruler and draw a dotted line across. That's what it should be. However, the overall energy change is wrong. Okay, overall energy change needs to point from reactants to products. So it shouldn't be, the arrowhead shouldn't be down there. The arrowhead should be up here. Okay, right, on to the next one. Here, nice and easy. These should not be double-headed arrows. So activation energy should not have an arrowhead there. It's pointing from the reactants to the top of the curve. And the overall energy change points from the reactants to the products. So it should not have one there. Okay. Next. Again, nice and easy. These aren't long enough. So the activation energy needs to go from the reactant. So it should be starting down here. And it should go all the way up to the top of the curve. So if I draw on a line there, I know that it needs to go all the way up to there. Okay, and for the overall energy change, that needs to go from reactants to products, so it should start down here, and it should go all the way up to the products. Okay, this one. Okay, so now a lot of people, they got upset because they thought, well, I've been drawing the overall energy change over here and the activation energy over here. Now, technically, it doesn't matter where you draw the arrow as long as it's clear what that arrow indicates. Okay, so this overall energy change, that's correct. There's no problem with that. It starts at the reactants and it finishes at the products. Yeah, so this is the line of the products. So if I wanted to, I could draw this out here. So it starts at the reactants and finishes at the level of the products. Okay, now most people have drawn it over here, right? And that's fine. It doesn't matter where you draw it as long as it starts in the right place, finishes in the right place, and is labeled correctly. So that's fine. The problem is the activation energy. Okay, now a lot of people thought that the activation energy is wrong because it should be over here. And that's not the reason. Okay, the problem is the activation energy needs to start at the reactants and finish at the top of the curve. So really, the activation energy shouldn't have any of this on it. Okay, so if I draw the activation energy arrow like that, that would be fine. Okay. Next. All right, so now it should be fairly straightforward. The activation energy arrow is not long enough. It needs to start down here. And the overall energy change, that's fine. Starts at the reactants, finishes at the products. This one, I think most people were fine. Yeah, it doesn't go down like that. Okay, that's not possible. All right, so that's wrong. It should look like this. Okay, which then means that it's, technically for the curve that I drew, the activation energy was right. Okay, but obviously now for the correct curve, the activation energy should be that. Okay, but the overall energy change is fine. That's correct, because it starts at the level of the reactants and it finishes at the level of the products. No problems there. Okay, all right. This one, all right. I think most people had a really good go at this, actually. So the activation energy, that's fine. The overall energy change arrow is fine, okay, because it starts the reactants, finishes at the products. But this is your problem here. Okay, and I think most people noticed that if it's minus 50, then the arrow should be going down. Now, some people said, because this is minus 50, the arrow should be pointing downwards. Now, you can't do that, because the arrow must point from the level of the reactants up to the level of the products. So, what it means is you must have a positive energy change. That should be a positive energy change. Next, all right, obviously, there should be arrows. Okay, you can't just write on overall energy change plus 100 kilojoules per mole. All right, you need to have an arrow on there. Okay, so you would have to have somewhere, I guess it doesn't really matter where it is. Let's say if I bring that line out there. Then I can draw in the overall energy change. Okay, so now that looks much better. Okay, and yeah, you can go ahead and you can draw the activation energy on it as well, if that's required. This one, well, it's not an arrow. That's the problem, isn't it? Okay, it needs to be an arrow. Okay, and again, some people thought this was in the wrong place. The place isn't that important. You know, you can draw it over here if you want. I've just happened to draw it here, but I've drawn it correctly. And you should also have, if it's required, the activation energy arrow would be there. Okay, and finally this one. So this one, I don't think anyone got this one. All right, so yes, it's not labelled. Okay, I should have labelled it to make everyone happy. Everyone gets upset if I don't label it, and rightly so. You know, I should have labelled it. Don't just draw arrows on and not label them. So yeah, if you said it's not labelled, you know, you get some credit. But there's another problem. Some people noticed the equation wasn't balanced. Correct, yes, the equation's not balanced, let's not worry about that. The big problem though is if you think about this from a chemistry point of view, does it make sense? Well, what's the reaction? This is ethane combusting. It's combustion of ethane. Now you know that combustion of ethane, well, it's a combustion reaction, so it should be exothermic. But I've drawn an endothermic reaction profile. You see the energy is going up, whereas if it's exothermic, energy is released, so energy goes down. So really, this whole thing is wrong. It's all wrong, right? And it should be, I'll just do a little one here, it should be one of these ones, one of these exothermic ones, because it's an exothermic reaction. All right? Okay, good job on that one.